Hey everyone, it's Dan at SPE Motorsport. On this week's product spotlight, we're going to go over our new Billet intercooler for the 2011 to current 6.7 Powerstroke. Start off here going over kind of why we did what we did and why we even went forward and actually did a billet intercooler. So there's a lot of limitations with the factory one. Some of the limitations are it's restrictive, and it's also the design of the intercooler that is a limitation. The intercooler itself is a brazed style assembly, so each part of the core is actually a layer, and they kind of overlap each other with basically like a solder joint, and it's heated up, cooked together, kind of formed as one unit. It's a very cost-effective way of doing it, a very inexpensive way of doing it from the factory. The one nice thing about doing it that way, from other than just those key points, is the fact that it actually does cool well. The factory intercooler isn't inefficient from a cooling aspect, but it's very inefficient from a horsepower aspect. When we start talking about flow, passing the air through the core to get it to the engine, it's very restrictive. So it cools well, but it's restrictive, and also because of the way that it's designed and the cores being stacked on top of each other and kind of heated and soldered together, it's very easy for pressure to cause the intercooler to separate. If you're doing, you have a tuned truck, if you're running a compound setup or a non-VGT setup where you're seeing much higher than factory boost, the factory intercooler is very prone to failing. What happens is that pressure will build up and it'll actually start to separate the core. You'll notice the truck will smoke, it'll use up coolant on the secondary cooling system. You'll find it in the intercooler pipes. It could be bad enough that I've even seen trucks hydrolock. From a performance standpoint, that is a big problem. Moving on, we obviously wanted to package the best cooling that we could in the factory area. The area that we wanted to fit the intercooler in obviously had to work with within the constraints of the factory intercooler. What we ended up doing is we looked at not just the dimensions of the factory intercooler, but the mounting locations, the positioning of the hot side and the cold side. Those were all things that needed to be taken into account. If you physically look at the two intercoolers side by side, you can see that our Billet one is quite a bit larger. The nice thing is though, we not only took into account the size of the factory intercooler, but the space that it went in. We wanted to package as much as we could in that same spot without interfering with anything else like radiator hoses and other, clearance on belts and fender liners and everything. So after we scanned the interior of the truck, we dimensioned everything, made sure that we could get it to fit in there, and then obviously we would 3D print one. The 3D print one's actually up here. So there was a couple things early on that we ran into with the intercooler in initial stages of testing. This has been something that we've been working on for many years now, and one of the main factors of even intercoolers that are available on the market right now is the fact that the core of the intercooler is usually a core that is designed to be used with ice water. A standard liquid to air intercooler core, an aftermarket style one, is normally designed to work with iced water or much cooler than ambient temperature for it to function efficiently and very well. So a lot of, I don't want to say brand names, but a lot of the intercoolers on the market right now actually have that issue. They don't cool well enough because the factory trucks are actually pumping temperatures of 100 degrees, maybe a little cooler, water through the intercooler to cool it. So it's at ambient temperature or maybe above a lot of the times. So being being that we're trying to cool all this hot compressed air through this intercooler with water that's 100 degrees, the factory thermostats are between 100 and 110 degrees in the secondary system, being that we're trying to cool it with water that's that warm, an iced core doesn't work well. So we couldn't just go out and purchase a core that wasn't designed to work with iced water that's going to be pumping through there at 40, 35, maybe even cooler degrees to cool this air, because on the factory application we're obviously using 100-degree water, let's call it that. In initial testing, we used the same types of cores that a lot of the other manufacturers used, and it didn't meet up to our standard. We found a lot of shortcomings with it. We didn't like the fact that the water that was required to make them function good wasn't good in an application where you had warmer water. It just didn't work right. So at that point, okay, you could use it in a racing application where you would put a tank in it or whatever with ice, but in an application where you wanted to just drop it in the truck, cool better, eliminate all the downside factors of the factory intercooler, it wasn't up to snuff. We worked with a core company to actually design a core that they use in military applications that's designed that would work with that temperature, that would perform the way that we needed it to perform with that water that we were using to cool the air. So now that we had the intercooler core that we wanted to use, we had to figure out how we wanted to do the end tanks, and how we wanted to manufacture that. So we can cast them. We cast a lot of other parts. It was an easy route to go. We could have did a sheet metal style end tank. That was another easy route to go, where we would blow it out, bend it, weld it. Wasn't a problem. But there were downsides to all that. The sheet metal ones, depending on the application, if you're running 100 pounds of boost, they can balloon, pop open, they swell. The cast ones are really good, but part of the problem with casting is we need a solid wall thickness. We want a thickness, and we want to be able to make sure that strength's there, and being how tight some of these areas are, like at the bottom of the intercooler here, we wanted a nice cavity. We wanted to make it as thin as we could and still have all that strength. So we obviously didn't want to go that route. So the more and more we looked into it, we're like, you know what, as much as we don't want to do the billet aspect and go down that road, we wanted to, because we wanted everyone to see how well this intercooler could perform in every application, whether it was a stock truck or whether it was compound turbos. Well, it didn't really much matter. We just wanted to make sure that it was going to do the very best that it could. And after taking in all the key design factors and pushing this thing for years, this was the only way for us to go. Obviously, once we got to that point, we finished it. We did the rest of the design and billet, welded them together, and we started testing. So the testing process from that point on, I mean, we were well over a year in testing and trying things out after we got everything ironed out in a manner that we were happy with. So some of the stuff, some of the specs, we're going to go over in this video as well. We got some footage. We're going to cover a lot of that. I'll hit on some bulletins here, or some bullet points, things that we made better, things that were about the same. A couple of those are, and people may not even know this fact, but a couple of the things that I want to cover are the actual temperatures of the air coming in and the air going out of these intercoolers. The thing that people don't realize is you actually have 500-degree air in certain situations, compressed air entering into these intercoolers. So on the outlet, and we're going to actually show this, on the outlet of your compressor, you're seeing up to 500 degrees. And that was a lot of the testing we did with our Emperor kit. So VGT chargers can get even higher than that. The range from the air coming in to the air going out, that percentage of temperature drop, we wanted to stay very similar. And we were able to achieve that with our core. 500-degree air coming in, 100 to 150-degree air coming out. Depending on the situation and how heat loaded the system is, I mean, yeah, you can see 200, but we wanted to definitely keep it below that. We were able to achieve all of that. Some of the other things to touch on are actually pressure drop. So that's another thing that a lot of people don't think about in an intercooler situation or scenario. Whenever you're cooling air, you have to slow it down to some extent. So if you're pumping air through an intercooler, it has to slow down to be able to dissipate its energy, its heat, what you're trying to remove from it. So the back pressure that we were seeing across the core in the factory intercooler, we were seeing anything from 3 to 5 pounds of boost. So if we were entering in at, say, 5 here, we were coming out at 1 on this side, you know, or less. Our intercooler core is much more efficient, and it's a lot to do with the design and how the core is actually assembled. Our core was only seeing about 1 pound of pressure drop all the way up to 60 pounds of boost. We were only losing about 1, maybe 2 pounds, worst case scenario. So we started getting to the point where we were actually cutting pressure drop in half, which by cutting the pressure drop in half or less, it adds the throttle response, it helps torque, it helps everything. The outlet temperatures we were able to keep in check to something we were very happy with in almost every scenario. And what we were doing is we were actually, when we were doing testing on this, the abusive testing, we were actually loading our hub dyno a certain way so that we could actually carry it on as if though we're driving up a hill. So with a trailer on the back, just holding the truck at a set RPM and slowly letting it sweep from there.
So what that gauge is hooked up to is the hot side. We got compressed air, pre-intercooler running to that. Post-intercooler is monitored off of the cool side, the factory deal. We'll check that through EasyLink. And then pre-boost, post-boost, both go to the dyno.
So we were able to really test and watch EGTs, and that was a big thing. So we were actually able to drop the EGTs of the engine overall just by changing the intercooler. No tuning changes, nothing else. Just changing the intercooler out, we were able to drop EGTs by, in some scenarios, 100 degrees, which may not sound like a lot, but really is a lot. Even 30, 40 degrees is quite a bit. In terms of moving more volume through with less back pressure. The coolant temperature, or I'm sorry, the air outlet temperatures, sometimes depending on the situation, with this intercooler would be slightly higher, but EGT was always lower and the truck had more boost pressure at the manifold than it did with the factory intercooler. So every other factor was more to the positive. So we were cool with that. We did a lot of testing, basically back to back, you know, going from a factory intercooler to our intercooler and doing the exact same test across both. Even just getting power numbers, we did the exact same thing, and we'll show you guys that. Moving kind of down the line here, obviously the intercooler, it's a billet construction, it's all TIG weld. This is 100% made right here in the USA, in-house. We do everything in-house. The intercooler core obviously is supplied to us. We don't do that in-house, but every other aspect of it is done in-house. So the intercooler core, obviously, as I stated earlier, is the intercooler itself is a lot bigger than the factory one. The main thing that we were trying to do was fit as much as we could in the same area that this factory intercooler went. So whenever we did that, we actually made it as large as we could as far as the core goes, the end tank sizes, and tried to keep, you know, the positioning of all the intercooler hoses in factory location, all the mounting points, factory location. We were able to achieve that. We were able to make the size larger. This is a 6x6x12 intercooler core. So it's quite large. The intercooler is quite a bit heavier than the factory one. The quality, in our opinion, is bar none. I mean, we put a lot of effort into this thing. It really is a work of art. The cooling system, the way we're attaching to the cooling system is via -12 AN, male AN hose ends or fittings. So we'll actually provide a push lock style nice AN thread on hose or thread on hose end that'll go right on here, and you push the factory hoses on and you're done. So it's very simple setup. It even uses a billet style factory rubber, a billet hanger with a factory rubber grommet to slide it into the battery box. So all the factory mounting points, locations, water lines, all that stuff, they're all used just as you would with the stock intercooler. So we're really happy with how everything turned out. The intercooler itself, basically it outperformed what we thought it would. And by the time we were all said and done with the same truck, going from this intercooler to this intercooler, and now remember, this is all doing the exact same scenario. So this isn't dyno pulls on different days at different temperatures. This is a heat-soaked truck making a dyno pull. We were able to actually go and gain anywhere from 13 to 20 horsepower back to back between the two intercoolers. We also, now this is the kicker, we also gained on average 115 to 130 foot-pounds of torque on average between the two cores. And you're gonna say, well, that doesn't really add up. Why only a little bit of horsepower and a lot of torque? Well, the reasoning for that is when you eliminate that pressure drop and you get that throttle response and the turbo is able to move more volume through the intercooler, all of that hits the engine quicker, faster, and harder. So you get that air in and air out of the engine faster. So the engine's able to breathe better and just make more torque naturally. On the truck that we were testing this on, being that we were making about 700 wheel horsepower with it, the turbo that we had on the truck was basically out of steam. So the torque would hit nice and hard, but the turbo was rolling out on top. Like it didn't have enough volume to keep making more horsepower. So in an application where you would have a large enough turbo and be able to make more power, you're always going to make more power with this intercooler because of its size, less pressure drop, better core efficiency. So we're really happy with the power numbers and everything that we got from the jump from the stock intercooler to ours. So that being said, so obviously power gains, we talked about the back pressure, we talked about the pressure drop in that aspect. The other thing is, as far as like drivability, you're looking at changing from a stock intercooler to this one. We know about the back pressure, we know about power gains, we know about that. The efficiency of the intercooler, being that it's very similar to stock, you keep your cooling, but you add the responsiveness. So being that you make torque quicker, torque is actually the thing that you feel. Horsepower is a measurement. In that aspect, you're gonna feel that 100 foot-pounds that we gained in this particular test scenario. Once we took it out on the road, you can feel that. It's something that you can really feel in the seat of your pants. So being that the volume and everything flowing through the intercooler is much higher, that's where that kind of plays in. Your drivability is better, your throttle response is better, the turbocharger cruising, being that there's less back pressure, you'll actually see your boost gauge go up slightly when you're cruising. So being our Emperor, we were actually testing this on a truck that had our Emperor kit on it, which was a non-VGT truck. Cruising with the truck prior with the stock intercooler, we would see maybe 1 to 2 pounds of boost. Driving normal, flat ground, down the freeway. Now, putting the billet intercooler in it, we saw an increase to about 5 pounds of boost. So, it might not sound like a lot, but adding 3 to 4 pounds of pressure just in a cruising state, and then tipping into it from there and already having a couple more pounds of boost there on tap, turbo comes up a lot quicker. So that actually makes a big difference. And the VGT stuff, you'll see it even better because they're just naturally, the housing's tighter, it's more wicked up down low. so you're going to already have more boost. So that makes a big difference on the efficiency point of things. So that, you know, drivability, that's huge. The lower EGTs. So we were seeing about the same outlet temperatures as far as the air goes, very similar. Depending on what was going on, you know, full disclosure, we see a couple degrees higher coming out of ours because we are flowing more air through it. But the thing that we can say is that being that the volume and the less restriction on the motor, what we noticed immediately was the lower EGTs. So as I touched on earlier, that was another key point. You know, about 100 degrees we're seeing on average in almost the whole, you know, rev range of our testing. So lower, and then the horsepower and torque gains, as we already covered, was a big deal. We're pretty happy with what we've got sitting here in front of us now. We took quite a while to get to this point. We did a lot of testing, a lot of changes. A lot of times we looked at the market and said, oh, there's already a bunch of intercoolers out there. But we weren't going to give up. We kept pushing, and we finally have something that we're happy with, that we want to release to, you know, our customers. So the intercooler, if you're watching this video, it'll be on the website, ready for purchase today. We're pretty pumped about this, and we hope everybody else likes it as well. If you have any questions, comments, anything that you need a hand with, you can give us a call. You can reach out to us on social media or email, and we'll catch you on the next one.